Hello class. So in this video, we are going to discuss chapter 4 and that is linear differential equations of order n. So in the previous na mga chapters or videos natin, so far, ang diniscuss natin are only differential equations of order n. Or to be specific, yung mga sinolve natin na differential equations, yung order nila is just 1. So, kung napansin, nag-applications tayo, nag-solve tayo ng exact equation, Bernoulli equation, etc. etc. Pero ang order nila, laging order 1. Wala tayong nakitang second derivative, third derivative, etc. etc. Now, this time around, we are going to study differential equations of higher order na, hindi lang order 1. Again, ang atake natin dito is katulad pa rin nung nakaraan. We are trying to know the theory, paano ba mag-solve ng differential equations of order n. Kasi in the future, gusto natin, gamitin natin siya to solve real-world na problems. So, kung sa first few chapters, inaral natin yung order 1 equations in preparation for applications of order 1. So, ganun din dito. We'll be studying differential equations of higher order because we are going to solve real-world problems na higher order na yung mga differential equation natin. So, ganun pa rin yung mangyayari dito. Now, for this video, introduction pa lang to. And mostly, ang gagawin natin dito is understand the concepts and improve kung paano ba natin pwedeng makuha yung solutions to differential equations. Now, pwedeng medyo mahirap intindihin tong chapter na to or itong part na to. But kapag nag-solve na tayo ng actual na mga differential equations, madali na siyang intindihin. Ayan. So, first is, let us define muna ano ba ang differential equations of order n. So, the general linear differential equation daw of order n is an equation that can be written in this form. That is b sub 0 of x d raised to n over y dx raised to n plus b sub 1 of x d raised to n minus 1 y over dx raised to n minus 1 plus plus b sub n minus 1 of x dy over dx plus b of n b sub n of x times y is equal to r of x. So, kung napansin, it's just coefficients. And to be specific, itong mga coefficients na to ay functions. So, we have functions of x multiplied to derivatives of different order. So, let's say, for example, ang order mo ay n, then this is your higher order. It is multiplied to a function of x, b sub o of x. So, yun plus yung general form natin. And so on and so forth hanggang makarating tayo sa dependent variable, in this case, which is y, na wala ng derivative. So, we can also express this in this form. Instead of d squared x or dn y over dx raised to n, yung prime na lang, di ba, yung ginagawa natin. So, pwede natin siyang express ng ganito. Instead of dny or d raised to n y over dx raised to n, gawin na natin y, then open close parenthesis, ang nasa loob niya is n. So, understood na kapag ganyan yung expression, ibig sabihin nun class ay, that is the derivative, not, hindi siya naka-raise to that number. It is that derivative. So, kung nakalagay dyan is 3, then that is y, triple derivative, yung tinutukoy natin doon. So, hindi na advisable na ilalagay pa natin yung 4 na apostrophe, 5 apostrophe, di ba? So, ang ginagawa na lang natin dyan is parenthesis na sa loob nun kung ano yung order niya. So, similar lang itong dalawang to. Iba lang yung pagkaka-express natin. So, tandaan lang yung sinabi ko kanina, yung y na may parenthesis na raised to n dito, hindi siya talaga naka-raise sa n. That's the derivative. So, kung meron tayong n is equal to 2, then that is y double prime. Y parenthesis, tapos 2, close parenthesis, or y double prime. So, yun yung tinutukoy natin dyan. Yan. For example, this is a differential equation. Order niya ay 2 lang. Diba? So, mukhang simple lang siya. Pero actually, ito na rin yun. This is the same problem, same format siya. Nasa same general equation siya ng isang higher order differential equation. syempre, mas mataas yung order, mas komplikado yung expression natin. But ito, second order lang kasi. So, kung mapapansin, ito yung coefficients natin na functions, 3x saka x minus 1. Tapos ito yung mga derivatives. Tapos naka-multiply siya sa, naka-equate siya sa r of x natin. In this case, this is cosine x. So, isa-isayin natin, no, para mas madali. Let us first identify what is the order ng equation. Yung order ng differential equation, yun lang naman yung zero natin, yung nakamultiply sa highest order derivative. In this case is ito. So, ang b sub o natin is 3x. Now, b sub 1 natin is equal to x minus 1. Now, hindi ko na sinulat, pero we also have yung b sub n natin, that is b sub 2. Yun yung nakamultiply sa y lang, yung hindi nakaderivative yung y natin. And in this case, yung b sub 2 naman kasi natin is just equal to 1. And then, okay, mali. Ang ating r of x is cosine x. So, sorry about this one. Yan. So, this is cosine. So, this is, ibig sabihin, itong equation na to, nakabase talaga siya doon sa general equation natin kanina. The only difference is, ayun nga, mas simple na siya. Konti lang kasi yung terms niya kasi ang order niya is just 2. So, konti lang yung terms. Pero this is the same format nung kanina. So, yun nga kasi minsan komplikado lang siya tingnan kapag yung general equation titingnan natin kasi syempre applicable yun for any order. Pero kapag in-apply na natin siya to an actual expression, madali na siyang intindihan. Now, let's look at this concept. If the value daw of the function r of x, meaning kung saan tayo naka-equal, ay 0 for all x, meaning yung cosine x natin wala. This is equal to 0. Then the function or the equation is said to be homogeneous. So, yung homogeneous dito, iba to dun sa tinutukoy natin, homogeneous differential equation na discuss natin in the previous chapter. So, different na homogeneous yung ibig sabihin natin dito. Pag sinabi natin homogeneous at ang pinag-uusapan natin ay higher order differential equation, ang ibig sabihin lang nun class, naka-equal siya sa 0. Or to be specific, wala tayong r of x. Meaning, wala tayong function of x kung saan naka-equate yung lahat ng dependent variables natin. So, another concept is what we call the interval. So, if the coefficients of the function b sub o, b sub 1, up to b sub n, and the function r are continuous on an interval I, and b sub o of x is never 0 on I, then the equation is said to be normal on 1. So, ano lang ibig sabihin nun? Kasi syempre, di ba, nagsosolve tayo kapag nagdi-differential equations tayo, may interval kung saan pwede natin gamitin yung equation, kumbaga. If usable, yung equation na yun to that certain interval, then that is normal to that interval. Pinapangalanan natin yung set of values of x na yun as I. So, yun yung set natin. That's the interval. So, para mas maintindihan, tingnan natin itong example na to. We have x minus 1 dy over dx plus y is equal to sine x. This is just a first order differential equation. So this is our b sub 0 of x. So yung x minus 1 natin, this is our b sub 0 of x times dy over dx plus y is equal to sine x. Ito naman yung ating rx. And then yung 1 dito, that is our b sub 1 of x. Now, this is a first order linear non-homogeneous differential equation. Bakit? Itong linear first order non-homogeneous, ang dali nating malaman. Yan, kasi na-discuss na natin. Now, paano natin nasabi that normal siya on any interval that does not contain x is equal to 1? Remember from the description earlier, kailangan daw normal ang isang differential equation to one interval if your b sub 0 of x is not equal to 0 in that specific na interval. So, your b sub 0 of x is x minus 1. So, kailan lang magsi-0 itong b sub 0 of x natin? That is at x is equal to 1. If x is equal to 1, makakancel yan. This will become 0. So, therefore, that is not normal in that interval. However, it is normal in any interval basta hindi siya equal to 1. As long as hindi ka dadaan sa equal to, x is equal to 1, then normal yung equation mo on that interval. So, therefore, kung ang equation mo kung ang interval mo ng x, halimbawa, magbigay ako ng interval. Ang interval ko ay from x is equal to 0 to negative infinity. From 0 to negative infinity, never na magiging x is equal to 1 yung value. So, therefore, ang equation natin is normal on this interval. Now, what if ang interval ko naman is 1 to positive infinity? Is the equation normal in this interval? No. Bakit? Kasi at x is equal to 1, magsi-0 yung b sub 0 of x natin. So, this is not normal on this equation. However, if yung interval natin is 2 to infinity, di ba? There is no chance na magiging 0 yung b sub 0 of x natin. So, therefore, normal ako dito. So, normal ako dito. I'm not normal here, but normal din ako dito sa interval na to. Yan. So, yun yung tinutukoy natin about normality pagdating sa intervals. Another example, we have 3 d squared y over dx squared plus xy is equal to 0. So, ang kailangan lang natin tingnan is yung ating b sub 0 of x. And ang b sub 0 of x natin dito is 3. Now, is there any value of x na kapag sinubstitute mo ay magsi-0 yung 3? Di ba wala? Kasi in the first place, hindi naman nakamultiply constant si 3. Di ba? Walang nakamultiply sa kanya na any variable. Or hindi nakamultiply sa kanya yung variable na x natin, which is what we look into dun sa interval. So therefore, this is a second-order linear, homogeneous, and normal equation in any interval I. Meaning kahit anong interval mo, hindi siya magsi-0. Ayan. So we are now going to discuss the solution to higher-order differential equations. You will be seeing familiar concepts on differential equations that we have discussed in last time. So for this discussion, again, magpo-prove lang tayo. We are going to prove different concepts because those concepts ay gagamitin natin sa pagdidiscuss kung paano ba tayo nagsosolve ng differential equation. So dito, we will try to solve differential equations, yes. Pero, kumbaga hard na part pa tayo. Difficult level pa. Tapos, kailangan lang natin maintindihan yung difficult level muna, kumbaga, para pagdating doon sa mas madaling solution or practical solution is na-understand pa rin natin yung concept. Ayan. So remember daw that in a differential equation, the solutions are functions. So hindi mga numbers. Now, if let's say for example, gamitin natin yung differential equation natin kanina na ito, yan lang naman yung general form natin. Then, if a function y sub 1 is a solution to this equation, then kapag sinubstitute mo to dito, it should satisfy the equation as well. So if we substitute y sub 1, sa expression, pinalitan lang natin, imbes na y sub 1, kung ano ang prime yan, y sub 2, y sub 2 tuloy, y sub 1, prime na lang to, then y sub 1. Then this also must be true. True din to dapat. Kasi masatisfy nyo dapat yung equation since it is a solution to that problem. Ito napaka-basic kasi napag-aralan natin yan last time. That is also where we started nung diniscuss natin yung solution ng mga first-order differential equation. So, nag-a-apply din yan sa second-order or higher-order differential equations. Now, ang ipoprove natin ngayong class is that if y1 and y2 or y sub 1 and y sub 2 are solutions of the homogeneous equation, this one, so tinanggal natin yung 0, homogeneous na siya. Ay, tinanggal natin yung r of x, so ginawa natin yung 0. It's a homogeneous differential equation. If y1 solution dito and y2 solution din dyan, we will prove that y is equal to c sub 1, y sub 1 plus c sub 2, y sub 2 is also a solution to this equation as well, given that c sub 1 and c sub 2 are constants. So, ang sabi dito, class, kung si y sub 1 ay solution dito at si y sub 2 ay solution din dito, then the combination of y sub 1 and y sub 2 multiplied to respective constants, c sub 1 and c sub 2, ay isa ring solusyon sa equation na to. Meaning, this combination of y sub 1 and y sub 2 multiplied to their constants will also be a solution to this equation. So, yun yung gusto nating patunayan dito. So, let us start with our proof. So, the statement that y sub 1 and y sub 2 are solutions in the equation means that we can substitute them to the differential equation and then it will satisfy the equation. So, thus, ito na yung kanina natin. Sinubstitute natin yung y sub 1. This must be true because y sub 1 is a solution to the homogeneous equation. And then, pangalanan natin siya na equation 3 para lang di natin makalimutan. And then, gawin din natin siya for y sub 2 naman. So, kung y sub 2 is a solution, then this also must be true. Now, itong dalawang equation na to ay true. Sabay natin ngayon siyang gagamitin sa pagsosolve ng ating differential equation. Or paggagawa ng proof natin about the solutions of differential equation. So, sabay natin siyang gagamitin. Now, ang intention nating class is makuha natin yung y sub yung y. The intention class is makuha natin yung y is equal to c sub 1, y sub 1 plus c sub 2, y sub 2. So, hindi ako sigurado kung na-discuss nyo to sa dati kasi may discrete mathematics. To tinuturo yung proving. Hindi ko lang sigurado kung isang subject siya na nakapasok ngayon. But gusto nating makarating dito sa expression na to. We want to prove na itong expression na to is also a solution to the equation. So, therefore, gusto natin is maging kamuka nung current na working equation natin, itong gusto nating kalabasan. So, therefore, para makamukha yan, yung merong y1 na equation natin, which is equation 3, multiply natin sa c1. And then, yung merong y2, that is equation 4, i-multiply natin siya sa c2. Para, ayun nga, magkaroon tayo ng c2, c1, tsaka y2, kumbaga. If we do that, so we will have, for equation 3 muna, minultiply natin yung whole equation by c1. So, we will have this equation. So, same yung equation lang din, multiply ko lang sa c1. So, hindi ko na isa-isahin, sabihin. And then, another equation, yung c2, minultiply mo sa equation 4, we'll have this equation. Now, kung mapapansin natin, in these two equations, maraming similar. Kumbaga, we have itong b sub 0 of x, b sub 0 of x, parehas lang yan. And so on and so forth. Now, since both of these equations are equal to 0, ang pwede rin natin gawin, class, is i-add natin sila. Because itong gusto nating marating na equation, itong dalawang equation na to. If we add the results, we will get this equation. So, hindi ko na rin babasahin yung mismo equation since this is this equation plus this equation. Then, equal sila sa 0. Now, ang gagawin natin ngayon is to factor out the coefficients. To be specific, ang tawag natin dito sa b of sub 0 of x na yan ay coefficient functions because they are coefficients tapos function sila. So, ito, like, itong b sub 0 of x na to, ito rin yan, no? B sub 0 of x. So, if we do that, factor out natin siya, and we group the terms, we will have this equation. Kinuha natin yung b sub 0 of x, tapos yung b sub 1 of x, hanggang sa b sub n of x, tapos equal to 0. Now, kung mapapansin, we have c1, y1 raised to a certain derivative, c2, y2 to a certain derivative, and by rules of derivative class, we can just say na itong c sub, halimbawa, gawin natin first derivative. If n is equal to 1, then ito siya. Kung n is equal to 1, we will arrive at c sub 1 y sub 1 prime plus c sub 2 y sub 2 prime. However, it is by rules of derivative, alam naman natin na this is also equal to the first derivative of the whole equation. So, c sub 1 y1 plus c sub 2 y2 to the first derivative, that is equal dito. So, isimplify na lang natin siya. So, pag sinimplify natin siya, magiging c sub 1 y sub 1 plus c sub 2 y sub 2 tapos naka-raise siya to naka-raise tuloy. Ang derivative niya to the nth na order. So, pwede natin siyang i-apply in all of these terms kasi pare-parehas lang naman siya. Now, if we directly substitute c sub 1 y1 plus c sub 2 y2 to the equation 2, yung working equation natin, we will arrive at this very same equation. So, therefore, if this is true, from our proof na ang pinagdaanan natin is sinubstitute muna natin si y sub 1, si y sub 2, etc., etc., at equal lang yung expression makukuha natin kapag directly sinubstitute mo to sa sa equation 2 natin. Then therefore, this y sub 1 y is equal to c sub 1 y sub 1 plus c sub 2 y sub 2 is also a solution to this equation. So, this is our proof ngayon. So, you may pause the video and then ang gawin nyo class is itong mismong function na to, y is equal to c sub 1, y sub 1 plus c sub 2, y sub 2, directly nyong i-substitute dito sa equation na to. Not this one. Ayan, dito. Substitute nyo siya directly to this equation. And kapag ginawa natin siya, ang makukuha nyong sagot is similar to this one or exactly this one. So, ito yung kakalabasan. So, ganun class yung pagpo-prove natin that a combination of two solutions is actually also a solution to the is also a solution to our differential equation. Now, in a similar manner, so we can repeat this process for y sub I and c sub I with I is equal to, let's say, for example, 1, 2, up to a certain value, let's say k. And all will be solutions of equation 2. So, halimbawa, ang n mo mataas. So, you can have various combinations and all of those combinations will also be solutions to your differential equation. So, therefore, we can simplify or we can have a general definition of our combination, and that is y is equal to c sub 1, y sub 1 plus c sub 2, y sub 2 plus plus c sub k, y sub k. Depende kung ilan yung solutions na meron ka. Kung meron ka 4 na solutions, then you have 4 terms. Kumbaga, yung combination na yun, makakabuo ka ng 4 na terms. So, ganun class yung pag-define natin nun. Now, ang tawag natin dito ay linear combination. So, we call this linear combination. Because basically, it is a combination of different solutions. Now, take note, itong general form na to, or itong equation 6 natin, that is just the solution, na general. Bakit general? Kasi class, we have C1, C2, up to C sub k, and those are arbitrary constants. And as long as may arbitrary constants pa tayo, hindi pa natin siya magagamit to solve for the actual parameters. So, ang kailangan natin ngayong gawin is i-apply yung mga initial conditions natin. At kapag in-apply natin yung initial conditions, makukuha natin yung particular solution natin. Ayan. So, any linear combination of solutions of a homogeneous differential equation is also a solution. Ito yung statement natin. If you have y1, y2, up to yk, any combination ng mga yan, gagawan mo ng ganitong equation, ganitong form, those are solutions to your homogeneous linear differential equation. So, kailangan kasi alam natin tong concept na to or may proof tayo dito because i-apply din natin siya sa mga next na discussion natin dito sa chapter na to. Ayan. I-apply natin sa example para mas madali natin maintindihan. Let's have a very simple one lang. Find the general solution to the differential equation y double prime plus y is equal to 0. if sine x and cosine x are solutions to the differential equation. So we are asked for the general solution. Pero binigyan tayo ng dalawang solution, pero ang hinahanap is the general solution. So, ang tanong, paano natin hanapin yung sagot? So, very simple. We just use equation 6. Diba? So, we have y is equal to c sub 1, y sub 1 plus c sub 2, y sub 2. Second derivative lang siya. So, second order. So, therefore, dalawang terms lang yung magkakaroon tayo. Now, sin x daw and cosine x are solution. Let us substitute. So, ibig sabihin, this is our y sub 1 and this is our y sub 2. Substitute natin siya. So, we will have yung y is equal to c sub 1 sine x plus c sub 2 cosine x. Based from our proof earlier, itong equation na to, class, is a solution to this equation. So, therefore, kung ganun yung case, that is our general solution na. Yun na yun. Diba? Sobrang dali lang. Next, using the same problem daw, hanapin natin yung particular solution if may initial conditions tayo that y of 0 is equal to 0 and y prime of 0 is equal to 1. So, ano lang ba yung sabihin nito? Ibig sabihin lang naman ito, class, at x is equal to 0, y is equal to 0. And at x is equal to 0, y prime is equal to 1. So, pwede na nating makuha ngayon yung particular solution natin. So, take note, dalawa yung binigay sa atin na general ay na initial condition. Bakit dalawa? Kasi dalawa din, class, yung constant natin. So, you need two equations para makuha natin yung mga values nila since dalawa yung unknowns natin. So, based from the initial conditions, we have when x is equal to 0, y is equal to 0, excuse me. So, substitute natin. Again, ang equation natin na nakuha kanina, isusulat ko lang ulit. Y is equal to c sub 1 cosine x, sin x pala. Sin x plus c sub 2 cosine x. So, substitute natin. Y is equal to 0. All x's are 0. We will have 0 is equal to c sub 1 sine of 0 plus c sub 2 cosine 0. Sine 0 is just 0. Cosine 0 is 1. So, therefore, C2 natin is equal to 0. Next, kunin naman natin, gamitin natin yung second initial condition. That is at x is equal to 0, y prime is equal to 1. So, since hindi pa naka y prime, wala tayong y prime sa equation, kailangan nating i-derivative to. Kaya naman. Kunin natin yung differential ng buong equation. We will have, this is your equation, y is equal to c sub 1 sin x plus c sub 2 cosine x. Differentiate natin siya. We'll have y prime is equal to c sub 1 cosine x minus c sub 2 sin x. Substitute the initial conditions. Y sub 1 is equal, y prime is equal to 1. Ito siya. C sub 1 cosine 0 minus c sub 2 sin 0. C sub 2 sin 0 pala is equal to 0, so wala na yan. So, cosine 0 is equal to 1. So, therefore, ang C1 natin is equal to 1. We can now get the particular solution by substituting C1 and C2 to the general equation. So, we will have y is equal to sin x. This is our particular solution. Ayan, another example. So, find the particular solution of the initial value problem below if x cubed and x raised to the negative 4 are solutions. Tapos, may initial condition tayo na at x is equal to 1, y is equal to 4. And at x is equal to 1, y prime is equal to 5. So, madali lang din to. Start muna tayo with finding the general solution. So, to find the general solution, linear combination lang nitong dalawang solution natin. So, we will have y is equal to c sub 1 x cubed plus c sub 2 x raised to the negative 4. This is your general solution. So, linear combination lang siya. Next, let us find the particular solution by substituting the initial conditions. So, we will have when x is equal to 1, y is equal to 4 daw. Substitute natin sa equation. we have 4 is equal to c sub 1 times 1 raised to 3 or 1 cube plus c sub 2, 1 raised to negative 4. So, parehas lang tong 1. Ito rin is 1. So, we will have c sub 1 plus c sub 2 is equal to 4. So, this is our first equation. So, hindi pa natin agad nakuha yung value ng C1 at ng C1 or ng isa sa kanila, but at least meron tayong equation nila or relation nila. Next, apply naman natin yung second initial condition, that is at 1, ang x, y prime is equal to negative 5. So, first natin gawin is i-differentiate muna natin yung equation natin para magkaroon tayo ng y prime. So, we will have y prime is equal to c sub 1 times 3x squared minus c sub 2 4 times 4x minus 5. So, power rule lang yung ginamit natin dito. So, 3 na multiply sa 3, tas minus 1. Tapos ito, minus nilabas na natin kasi negative 4 yan. Tapos minus na natin ang 1, so naging negative 5. Substitute na natin yung initial condition. Y is equal to 5. So, 3 times c sub 1 because 1 lang to. Ito 1 lang din. So, we will arrive at wala pala tayong makukuha. But because meron tayong 2 equations, 2 unknowns, we can solve for C1 and C2. So, pwede nyo i-calculate lang yan directly or napakadali lang din naman. Palitan nyo lang yung isa. So, madali na siya, self-explanatory na. After solving, we will arrive at C sub 1 is equal to 3 and C sub 2 is equal to 1. Sorry, excuse me. Then, substitute na natin siya sa general solution. We will have a particular solution that is y is equal to 3x cubed plus x raised to negative 4. Yan. So, at this point, ang pwede nyong gawin class is mag-ano tayo, i-pause nyo yung video or actually tapos na rin yung video. This exact na equation ay i-substitute natin dun sa ating general, sa ating differential equation. Dapat masatisfy natin yung equation niya. Ayan. Ayan. So, that is it for this video. In the next video, we will proceed with another topic which is linear independence naman.